Everybody loves pie. Apple, cherry, pecan, key lime for my Florida people. But the kind of pie you don't want floating around your data stack, personally identifiable information. And the problem is, most teams don't actually know where all their PII lives. That's exactly what we built Altimate Code to solve. In this video, I'm going to show you how using our data engineering harness, Altimate Code, you can look through it looks through your data, finds the PII, and then helps you mask it in your code. Then we'll actually run a dbt build command to make sure that everything is actually hidden afterwards. Let's dive into Claude and take a look and see how we can do just that. All right, so jumping into Claude, you can see that I've just actually ran my dbt job here. So dbt build results, all of our things passed with 2 warnings that we knew existed. So we're good to go here. So let's go ahead, and we have our Altimate Code set on plan. So it's not going to build anything yet. It's just going to talk to us about doing it. So I'm going to say, I'm worried that there may be PII in my data. Can you help me develop a plan to mask it? All right, so now it's going to go through the data and look and see if it finds any PII, and it's going to make a plan for us to mask that data so that the PII doesn't get out to a Power BI dashboard, or worse, to a stakeholder report where we obscure, we give information out that we don't want to give. So we'll let this thing run, and we'll jump back in whenever it develops a plan for us. All right, so Altimate Code has got done searching through all the models, and it shows you, what's great about Altimate Code is it's open source. It works with, any database, and no matter what SQL dialect you're working with, it can look through any of this. We're using DBT with Snowflake currently in this video, but it can work with anything. So it's looking through all my DBT models here. So you can see it read those models. It's checking the raw source tables in Snowflake here. So looking at the schema inspect, doing a little bit of SQL execute to look at some things here as well. So it gets as a thorough picture of the data, and here's the full plan. So we have a column name called host name and name in these tables. That is a PII type of personal name. Reviewer name, same kind of deal. Review text and comments, it has a high risk because who knows what it could put in there, right? Like, you've seen reviews on Airbnb. Who knows what could happen there, right? Listing URL, probably not, but could be. And then name again for raw customers, which is a personal name. So it says, before I finalize this, it has a couple questions for you. So it doesn't just do whatever it wants. It's asking some questions. So it says, what is the primary compliance concern driving this work? So we could say GDPR, CCPA, internal policy, not sure, or we can type an answer and make it what we want. So I'm going to say, let's do GDPR just for fun. Okay, so how should names, so host name, reviewer name, be handled in analytical models? So we can hash them, tokenize, dynamic masking policy, pseudonymize. That's a word right there. Pseudonymize and staging, or type our own answer. Let's see. We'll just hash them. Why not? For review text, we could accept the risk, drop it, apply masking policy from Snowflake, regex scrub unknown patterns. So that's what we're going to do. So it's going to strip phone numbers, emails, URLs from the text before storing. So we're going to do that. So it's going to search for those things using regex. I like that a lot. And then we'll confirm. All right, so now we've answered those questions for it. So now it says good choices. Those are well suited for GDPR. So here's the full proposed plan. So the PI masking plan says approach summary. It's going to do the things we asked. So hash the names, regex scrub review text. We're going to drop the listing URL because it's not really doing much there. And then applying a dynamic masking policy on raw source tables to restrict unmasked access to the account admin role only. Okay, so changes by file. So it's breaking down what we're going to do for each file. And then what does it not change? It's telling us that as well. And then one key decision before I start, one thing to confirm. Hashing reviewer name will break the surrogate key and fax review, which currently uses reviewer name as one of the inputs. I'll update that to still use the hash value. Wanted to flag it explicitly. Okay, so we will accept the change and do a full refresh, which is fine. So it's just saying, hey, it's gonna mess some things up that we had before. Let's just make those changes. Okay, so total accept the change and do a full refresh. So now it's gonna give us the complete finalized plan ready for implementation. So files to create this mask PII text.sql, which is reusable regex macro to scrub emails, phones, URL from free text. We're gonna modify these 4 files here, and it has our DBT build impact. So all dim and mark models inherit masking automatically, and then fax review needs a full refresh run due to the surrogate changes there. And then out of scope for now are these 2 things, and then ask, should I go ahead and implement this? We're gonna say yes, go ahead and implement. Okay, and of course at this point, if you wanted to change the plan, here's your opportunity to do so. But we're just gonna let it go ahead and implement this change. And so what it's going to do is it's going to set up a to-do list for us, which we can see here. So we have create that macros mask PII test.sql, update those models, and then run dbt build with a full refresh to verify everything builds cleanly. So we're going to let this thing run, and then we'll jump back in whenever it's finished running. We'll go through the output of what happened during the run. All right, so Altimate Code is finishing up this whole process of masking the PII and building dbt out to make sure that it runs correctly. So let's go through what's doing here. And before it did anything, kind of during the middle of our time travel, it was like, hey, Steven, like it looks like you're in plan mode versus builder mode. So like I can't actually edit any files without your explicit permission. So I had to actually confirm it, that I had to give it the go ahead to actually do these 6 steps here, which is really great. You can see I switched over to builder now just because like I'm obviously building at this point. But again, just another really great kind of like guardrail that we've built into Altimate Code to make sure that, you know, your LLM doesn't go haywire, right? Like we've all had situations where we've told the LLM to do, like we've talked to an LLM about something and then like it just like changes 20 files or deletes files or does all these things. And it's like, whoa. I didn't want to do that. So we have some built-in protections for you just for that. So anyway, so let's go through what went on here. So we wrote a macro, this .sql macro. And again, we're not going to go through all of it, but it's this patterns of removing our email addresses. So this, you know, something at something.com something, phone numbers, URLs. So in these formats, they're going to get removed. And of course, again, I'm not going to go through all the regex here because first off, who knows how to read regex? I'm fully convinced regex is a thing that exists, but no one actually knows how to read it. But I'm sure someone will prove me wrong in the comments. So anyway, so now we're going to go through the models here and show, hey, like we're going to change, or we're going to do the SHA-256 hash for the host name here. So you can see that's what's being built out here with a little comment saying, hey, this is PII. We're going to replace it, right? Same thing going on here for my source reviews model. So again, same thing. We're changing reviewer name to a hash, and we're doing the mask PI text macro that we just showed off on the review text as well. So all good stuff there. Moving down to source listings, we're going to have the same kind of thing here. Listing ID, we're going to remove we're just removed the listing URL because it directly identifies the host public profile. So we don't want that. And then we went down here in the YAML file, removed that column. And then we're updating the descriptions, which is also cool. We didn't explicitly tell it to do that, but we knew that it changed some columns. We should change descriptions. So change host name, and now it says, hey, it's a hash of the host display name. The raw name is PII, and is hashed at the staging layer so that all downstream models receive only the anonymized values. The hash is deterministic. Joins on host name remain consistent across runs with a nice little meta tag here of PI, true, so on and so forth there, right? We're going to get the same type of thing here for reviewer name, and review text is also going to say, hey, like we've redacted email, phone, and URL. So they're replaced with these things here. Again, just updating your description because, listen, first off, you didn't see a video on writing DBT documentation using Altimate Code, go check that one out. I think that's a really cool video. But listen, no one likes writing documentation. Let the AI do it for you because it's writing the code for you. It's great. Same thing here for the listing URL. So this column is not propagated to any DBT model, so it's dropped in source listings. Name, so on and so forth there. Reviewer name, same thing. So anyways, going through the rest of the description there. So now we're down here at the bottom where we have run dbt build, full refresh to verify everything runs cleanly. So did that, ran it, and of course, I can expand this and show, like, hey, there's those 70 things that ran inside of dbt. Of course, probably don't want to see that with 2 warnings that we had before. But it says, hey, clean build, 0 errors. Let me fix the 1 deprecation warning that dbt flagged about the meta needing to live under the config and sources.yaml. So it found a weird, like this deprecation summaries here, which of course, if you use dbt, deprecation warnings are like almost, they happen all the time, right? So the AI is going to, or Ultimate Code is going to clean that up for us here as well. So cleaning it up with these new config meta versus just meta. So it did that all the way across, and then it reran that again. No deprecations warning, only 2 pre-existing data quality warnings. Everything's done. Here's a full summary of what was implementing. So we have a new macro. We changed the name to a hash, review name to a hash, comment scrub with the mask PI text comments. Same, our listings, we removed the URL. The schema, we've documented, or the schema.yaml and the sources.yaml we've documented well. So we have how it works end to end here, which is great. And then it's asking it says what to do next. So Snowflake diamond masking policies or this raw customers. We're going to skip that. And all I want to see at this point is I want to say, hey, I want to see what this looks like, right? So I copied that to clipboard. So I want to say, hey, so show me a sample of this, of the data from this table so I can visually see the changes. Okay, so now I just want to like take a look at it, right? Because I mean, obviously the AI told us that it did that stuff, but let's see if it actually did it. So, anyways, while it's doing that, I want to talk about a few other things that are happening here. So up here at the top right hand corner of our terminal, you can see we have our actual context there of how many tokens we're using, right? So in this whole thing, which began before the video started of me actually running my DBT models and things like that, we've used around 99,000 tokens, which is a total of $3, which it's not that much, right? That's pretty good. And just thinking about the fact that we masked all this PII for only $3, which is really exciting. And we're using Claude Sonnet 4.6, which, you know, I mentioned before a little bit, like kind of under the breath, but you can use any LLM model you want to use inside of Altimate Code because we're open source. We don't care which one that you use. Your choice. So you can use Anthropic's models, Google's models, OpenAI's models, along with a bunch of other ones, and we even have some free ones, some open source ones as well that you can use. So we'll let this finish running, and then we will pop back in whenever we get the results. All right, so it pulled a piece of data for us. So you can see the reviewer name before was Sarah. Now it's this crazy long hash. Review text. The text was preserved, but the PII patterns were replaced with these. And review ID was a surrogate key that still generates correctly using the hash name. So everything looks good there. It looks like it's hashing the names like we want it to, which was the big PII that we found inside of this Airbnb project. And you can see that it says to see the regex scrubbing in action, you need to find a review that contains something like that specific, with an email or a phone number or something like that. So definitely could go into Snowflake and search all that out, but the names definitely work, so we know that the review text also worked as well. So in this video, we showed you how Altimate Code can go through your database and look and find PII, and then actually write code to help mask it inside of either a DBT environment or any SQL environment, all in a very short amount of time and using a pretty small amount of tokens, which I think is really cool. So if you are, if your team is having trouble finding those PIIs that are existing in your databases, I'd love for you to check out Altimate Code. You can check out the link in the description. It's all open source on GitHub, so we'd love to see you check it out. We'll see you next time.